Hey everybody, this is Gradius, and today what we are going to be doing is we are going to be working on solving polynomial equations. Okay, so first what we're going to talk about is what's called the zero product property. Okay, now the zero product property says this: if we have a and b are real numbers, if I have a times b equals 0, so if I have the equation a times b equals 0, then either a can equal 0 or b can equal 0. There's two possible answers. Because let's say if a was 2, then b would have to be 0 because 2 times 0 equals 0. Okay, where if b was 2, that means a would have to be 0 because 2 times 0 would equal 0. So either a or b can equal 0. So there's actually two answers to this equation. So what we're going to do is we're going to bring that down here. When I have two multiplication problems here, I have one multiplication problem. I have x minus 4 times x plus 2. So in both of these, if I multiply these, this should be equal to 0. This is an equation, and I want to solve for x. I want to know what can x be to make this equation true. Well, if all of this inside the parentheses were to equal 0, and I multiplied it by whatever x plus 2 is over here, then my answer would be 0, because 0 times anything is just 0, so this would work. Where also, if I had x plus 2 was equal to 0, and I had x minus 4 over here, x minus 4 times 0, it doesn't matter what x is. If this is 0, then it's going to be equal to 0. So what I'm going to do is I'm going to use that and solve this equation and figure out what are the possible answers to make this equation equal to 0. So really what I'm going to do is I'm going to set up x minus 4 is equal to 0, because if I make this whole set of parentheses equal to 0, then the whole equation would be 0. And I'm also going to set up another equation where x plus 2 is equal to 0. So if I add 4 to both sides, that means x equals 4. And if I subtract 2 from both sides, I'll get x equals negative 2. So my two solutions for this equation are x equals 4 and x equals negative 2. Because if I were to plug in negative 2, so if I had negative 2 minus 4, negative 2 plus 2, and I multiplied these, I'd get negative 6 times 0, which is 0. It would work. Okay, if I were to plug in positive 4, I would have 4 minus 4, which is 0, times 4 plus 2, which is 6. 4 times 6 is 0, so it would still work out. So let's look at a couple more examples to see if we get the hang of it. So I have x minus 5 times x minus 1 is equal to 0. So I want to solve for x. So I'm going to set up two separate problems. X minus 5 equals 0. X minus 1 equals 0. So I'm going to add 1 to both sides. X equals 1. Add 5 to both sides. And x equals 5. So here are my two solutions, x equals 5 and x equals 1. And if we think about it, if I plug in 5 here, that would equal 0. So 0 times whatever's in here is going to be 0. If I plugged in 1, I'd have 1 minus 5 is negative 4 times 1 minus 1, which is 0. Negative 4 times 0 equals 0. Same thing down here. So I have 2x minus 4, x plus 4. If I multiply these, I get 0. So I'm going to separate into two equations. And they're both equal to 0. So now this one's a two-step equation, so I just have to add 4 to both sides. 2x equals 4, divide by 2, x equals 2. And then this one I can just subtract 4, x equals negative 4. So my solutions are x equals 2, or x can also equal negative 4. And I'm done. So that is how we solve polynomial equations that are already pre-factored. Now what I want to talk about is factoring the greatest common monomial factor. So now I don't have any parentheses. Okay, and what I want to do is first we're just going to talk about factoring the greatest common factor, and so that we actually create some parentheses, and then it makes it a little bit easier to solve equations later on. So what we want to ask ourselves is, what do these numbers have in common that I can divide by? So what common factors, if I wanted to factor out 12x plus 42y to its simple, factor it out, I would want to ask myself, what common factors do 12 and 42 have? And the first thing that comes to my mind is I know they're not divisible by, I know 12 is divisible by 12, but 42 is not. So 12 is not a common factor. But 12 is also divisible by 6, and so is 42. So if I were to divide these by 6, this is like the backwards distributive property. If I were to divide these both by 6, and I were to pull that division out so it looks like multiplication, 12 divided by 6 is 2. I still have my x. 42 divided by 6 is 7, and I still have my y. So the answer is 6 times 2x plus 7y. And again, it was very similar. It was exactly like the distributive property, but backwards. Because if I take 6 and I multiply it by 2x, I'm going to get 12x. If I take 6 and I multiply it by 7y, I'm going to get 42y. I'll get the same thing. So what I did is I found a common factor, and I'm just dividing them both out. But when I divide, I'm just pulling it out and putting everything else inside of these parentheses. So I want to do the same thing over here, but I also want to look at the variable. Okay. They both have an x in common, so I can actually factor out my variable as well. So first, I'm going to look at the greatest common factor between 4 and 24. And the greatest common factor is 4. I can divide both of these by 4. So I'm going to divide them both by 4. Okay, I know I'm going to have some multiplication here. And when I do that, 4 divided by 4, this will be 1. 24 divided by 4 will be 6. Okay, now I want to look at my variable. And I want to factor out the greatest common factor within the variable as well. So here's an x squared. Here's an x to the third power. That means I can actually factor out an x squared. You can factor out the highest power of both, the lowest power of both of these. So x squared is the lowest common power. So is the highest common power. I'm sorry. So I can factor that out. So what that means is if I factor out an x squared divided by x squared, it just cancels out. There's nothing else there. Okay. X to the third power divided by x squared is x. So I have, and again, this is like backwards distributive property. If I were to multiply this out into both pieces, I would have 4x squared plus 4 times 6 is 24. X to the third power. So I can always distribute back and see if I got the same answer, and I did. So I know that this would be all the way factored out. Let's look at another one. So let's look at factoring equations. Okay, I spelled equation wrong. Ignore that, please. So if I wanted to factor this equation, so I have a polynomial. It's all set equal to 0. So I'm going to factor it out so I can actually solve the equation. Because this, I'm not exactly sure how to solve this. Because I can't really set these both equal to 0 because it's addition. So what I want to do is I want to make it so it's two pieces being multiplied so I can set them equal to 0 and then solve that way. So I'm going to factor out 2x squared plus 8x. So the greatest common factor here, it looks like they have a 2 in common. So I can factor out a 2. Okay, but they also have x in common. And this is an x to the first, x squared. So that means I can just take out an x to the first power, just an x. So if I were to take out a 2x, if I were to divide this by 2x, I have left just 1x left. So I'm left with 1x. If I were to divide by 2x here, the x's go away, they cancel, and I'm left with 4. So I have x plus 4 is equal to 0. Now, because I'm just really multiplying these two pieces right here, I'm really back to what I did over here, where I just set both of these pieces equal to 0. Because if this is equal to 0 and I multiply it by all of this, then it's going to equal 0 anyways. And if this piece equals to 0 and I multiply by all this, it's going to be equal to 0. So I have 2x equals 0, x plus 4 equals 0. X equals negative 4, divide by 2, x equals 0. Here are my answers. And I can go ahead and plug these back into my original equation to see if it works out. So if I did 2 times 0 squared plus 8 times 0 equals 0, oh, I have 2 times 0 squared is 0, times 2, that's 0, plus 0 equals 0. It works out. If I were to plug in negative 4, it would work out. Okay? Let's look at another one. I want to solve this equation by factoring. I have 6n squared equals 15n. So now it's no longer equal to 0, and I have n on two separate sides of my equal sign. Well, what I need to do is I need to, and with any equation that we've ever done, we always want to get our variable to the same side so we can solve for it. So I want to move my 15n over to the left-hand side. So to do that, because it's a positive 15n, I'm just going to subtract 15n from both sides. So I'll have 6n squared minus 15n is equal to, when I subtract it, nothing else is over here. So what's equivalent to nothing is 0. Now we're right back to where we were before. Okay, so now I can try to see if I can factor out the greatest common factor. So 6 and 15, what's the greatest common factor? They both have a factor of 3. I have n squared n, so this is like n to the first, so I'm taking the lower degree. I can factor out the lowest degree. So I have n that I can factor out. So when I divide this by 3n, I'm going to have an n left over, and 6 divided by 3 is 2, so I'll have 2n. When I divide this by 3n, I'll have minus 5. And all of that is equal to 0. Now I can separate into my two equations, and I can solve from here. So here n would just equal 0. Add 5 to both sides. I'll have 2n equals 5 divided by 2. N equals 5 over 2. And you can leave your answers as improper fractions. You do not need to change them to mixed numbers or to decimals. And I'm all done. Let's look at one more example, or two more examples, and then we'll be all done with this video. A squared plus 5a equals 0. I need to factor out a common factor. So right now, the 5, and this is just like having a 1 in front, I can't factor out the whole numbers, the coefficients. But I can still factor out an a, because I have an a squared and an a. So I can divide both of these by a. So when I divide this by a, I'm going to have 1a left. When I divide this by a, they're going to cancel, and I'm left with a plus 5 is equal to 0. Now I have a equals 0 because I'm separating both pieces into two different equations, and I have a plus 5 equals 0. So a equals negative 5. So here's one of my answers, and then a equals 0 is my other answer. Finally, 3s squared minus 9s. Look for the common factor for the coefficients. 3 and 9 have the greatest common factor is 3. So I'm going to pull out a 3. S squared and s, they have an s in common, so I can pull out a 3s. When I divide this by 3s, this cancels, and I'm left with just 1s. So we can keep the 1s. Divide by 3s, my s's cancel. I'm left with minus 3, and all of that is equal to 0. So I have 3s equals 0. S minus 3 is equal to 0. So s can equal 0, and then s can equal 3. And here would be my solutions. Okay, that's all I have for this video. I hope this helped, and I hope you guys have a great day.